Hi students, welcome back to ChemOrgChem. So in this JEE Chemistry Insight series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. This is the question from JEE Advanced 2025. As per this question, here we are asked to find out the compounds that contains the most acidic hydrogen atom. So here you can see that there are four options are given. Let's solve together to find the correct option for this question. So before moving to our solution, let's talk about what is mean acidity. So acidity refers to a molecule ability to donate a proton, and it's directly related to the stability of the resulting conjugate base. For example, now you consider this compound A. So now you imagine when this compound A donate this particular hydrogen atom, resulting that generation of their corresponding conjugate base. So the acidity depends on the stability of that generated conjugate base. So let's moving on the key factors that affects the acidity. For example, charge, atom size, inductive effect, orbital hybridization, resonance and aromaticity. So all these factors are that affects the acidity of any of the compounds. So for example, now you consider this example. So this one is a cyclopentadiene. Since our question mostly related to cyclopentadiene related hydrocarbons, so therefore let's consider this cyclopentadiene. So now this one is a acid. Now you imagine, so this cyclopentadiene, one of the hydrogen atom donated to base. Here base we can consider that water molecule. So now this hydrogen atom donated to this water molecule, resulting that generation of their corresponding conjugate acid along with conjugate base. So now you consider another example. So now you see this compound. So now you imagine this hydrogen atom donate to this water molecule, resulting the generation of this conjugate acid and this conjugate base. Now you should compare this conjugate base stability with this conjugate base. So this conjugate base is highly stable since this fulfill the Huckel rule of aromaticity. Therefore, this cyclopentadienyl anion is aromatic stable, but this particular conjugate base is not stable. So based on this conjugate base stability, we can say that this hydrogen atom is more acidic hydrogen atom when compared to this hydrogen atom contains this compound. So based on this compound, let's solve together to find the correct option for this question. So just like that, now you take our option A. Now you imagine that this hydrogen atom donated to water molecule, so resulting that generation of conjugate acid and their corresponding conjugate base generation. So now you see this compound, I mean this conjugate base is either aromatic stable or not. So this compound is particularly resonance stable only. Let's moving on our option B. So now you donate this proton to water molecule, so resulting that generation of their conjugate acid and conjugate base. So this one also resonance stabilized. However, here you should see when this negative charge moves here, so resulting that this pi bonded electron move towards this carbon atom, so resulting that generation of new resonance structure. Now closely look this resonance structure. So here you see that. So this core is cyclopentadienyl anion core. So which means that this particular structure is stable by aromaticity, since this cyclopentadienyl anion obeys the Huckel rule. So let's moving on our option C. So now you take this proton to donate this water molecule, resulting the generation of their conjugate acid and conjugate base. So this conjugate base also stabilized by a resonance only. So let's moving on our final option. So now you donate this proton to water molecule, resulting the generation of conjugate acid and conjugate base. This conjugate base also stabilized by a resonance only. So as per our discussion, this particular conjugate base is highly stable when compared to the rest of the other option. So let's moving to the our question. As per our discussion, among the four answer, the correct option for this question is option B. That means that the most acidic hydrogen contained the compound is option B. That's it for today's problem. I hope this explanation has helped you to understand this concept. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.